Hello everyone and welcome back. In this maths video, we're going to learn how to graph a quadratic function using the vertex, the axis of symmetry, and the intercepts. By the end of this video, you'll be able to find the axis of symmetry of a quadratic function, identify the vertex, find the x-intercepts and the y-intercept, and use all of that to draw the graph. We'll look at 4 different examples today, each with slightly different characteristics, so we'll need to adapt our strategy as we go. Let's get into it. The graph of a quadratic function is called a parabola, and its general form is y equals a x squared plus bx plus c. There are 2 possible cases here, and it all depends on the coefficient a, the coefficient of x squared. If a is positive, the parabola opens upwards. You can picture it as a smiley face. If a is negative, the parabola opens downwards. Picture it as a sad face. And a can never be 0. If it were, the x squared term would disappear completely, and we wouldn't have a quadratic function anymore, just a straight line. Here's the good news. To graph a quadratic function, you really only need to remember one formula, and everything else follows from it. That's the equation of the axis of symmetry. The axis of symmetry has equation x equals negative b over 2a, where a is the coefficient of x squared and b is the coefficient of x. Once we have found the axis of symmetry, we can use it to find the vertex. The vertex always lies on the axis of symmetry, which means its x-coordinate is the value of x given by the equation of the axis of symmetry. To find the y-coordinate, we simply substitute that x value back into the original function. We can then move on to the intercepts. To find the x-intercepts, we set y equal to 0 and solve the equation that's left. To find the y-intercept, we set x equal to 0. One more thing to keep in mind, the graph of a quadratic function is symmetric about its axis of symmetry. So any point on one side has a matching point at exactly the same distance on the other side. We'll use that a lot when it comes to drawing our graphs. Right, let's put all of this into practice. Let's graph the quadratic function y equals x squared minus 2x minus 3. First, let's identify a, b, and c. There's no number written in front of x squared, so remember that coefficient is implicitly 1. That gives us a is 1, b is negative 2, and c is negative 3. Be careful with the signs here. b is negative 2, not 2. Since a is positive, we already know this parabola opens upwards like a smiley face. Now let's find the axis of symmetry. X equals negative b over 2a. Substituting a equals 1 and b equals negative 2 into the formula, we get x equals the negative of negative 2 over 2 times 1. The negative of negative 2 is positive 2, and 2 times 1 is 2. This gives us x equals 2 over 2, which simplifies to x equals 1. Therefore, the axis of symmetry is the vertical line x equals 1. Next, the vertex. Its x-coordinate is 1, the same as the axis of symmetry. To find y, we substitute x equals 1 back into the function. Y equals 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3, which gives us negative 4. So the vertex is the point 1, negative 4. Now let's find the x-intercepts. We set y equal to 0, which gives us 0 equals x squared minus 2x minus 3. This equation can be factorized, but we'll use the quadratic formula, as this is the method we'll apply throughout the video. Let's recall the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substituting in our values, we get x equals negative negative 2 plus or minus the square root of negative 2 all squared minus 4 times 1 times negative 3 all over 2 times 1. The negative of negative 2 is positive 2. Negative 2 squared is 4, and the last term gives us positive 12. So the expression becomes x equals 2 plus or minus the square root of 4 plus 12, all over 2. The square root of 16 is 4, which gives us x equals 2 plus or minus 4 all over 2. These give us 2 x-intercepts, the point negative 1, 0, and the point 3, 0. Now that we have found the x-intercepts, we can move on to the y-intercept. To find it, we set x equal to 0. This gives y equals 0 minus 3, which leaves us with y equals negative 3. So the y-intercept is the point 0, negative 3. Now we have all the key features we need to draw the graph. Let's begin by plotting the axis of symmetry, which is the vertical line x equals 1. Next, we plot the vertex at the point 1, -4. We can then add the two x-intercepts, -1, 0, and 3, 0. The y-intercept is the point 0, -3, so we plot that point as well. Since the parabola is symmetric about the line x equals 1, we can use the y-intercept to find another point. The y-intercept is 1 unit to the left of the axis of symmetry, so there must be a matching point 1 unit to the right at 2, -3. At this stage, we have enough points to draw the parabola. Since the coefficient of x squared is positive, the graph opens upwards. Starting from the vertex, we draw a smooth curve through the points, making sure that the two sides are symmetrical about the line x equals 1. And that completes the first graph. Let's move on to the second example. Graph the quadratic function y equals -x squared plus 4x minus 2. Here, a is -1, b is 4, and c is -2. Since a is negative, this parabola opens downwards like a sad face. We begin by finding the axis of symmetry. X equals -b over 2a. Substituting the values of a and b gives us -4 over 2 times -1. That is -4 over -2, which gives us x equals 2. We can then find the vertex. Its x-coordinate is 2. Substituting this value back into the function, we get y equals the negative of 2 squared plus 4 times 2 minus 2. That's -4 plus 8 minus 2, which gives us y equals 2. Therefore, the vertex is the point 2, 2. The next step is to find the x-intercepts. To do this, we set y equal to 0. 0 equals -x squared plus 4x minus 2. We then use the quadratic formula to solve this equation. Since a is negative in this example, let's pay close attention to the signs as we substitute the values. Substituting in our values, we get x equals -4 plus or minus the square root of 4 squared, minus 4 times -1 times -2, all over 2 times -1. Simplifying this gives us x equals -4 plus or minus the square root of 8, all over -2. 8 isn't a square number, so this square root won't simplify to a whole number. However, the square root of 8 is equal to 2 times the square root of 2, so the expression becomes x equals -4 plus or minus 2 times the square root of 2 all over -2. Dividing by -2 gives us two solutions, x equals 2 minus the square root of 2 and x equals 2 plus the square root of 2. These are perfectly valid x-intercepts, but because they contain a square root, they are difficult to plot accurately on a graph. So instead of using them, we'll find a different point that is easier to work with. First, though, let's find the y-intercept. To do this, we set x equal to 0. When we substitute 0 for x, both terms containing x become 0, leaving us with just the constant term. This gives us y equals -2. Therefore, the y-intercept is the point 0, -2. To find an additional point, we choose an x value close to the axis of symmetry. We only need to calculate one point, because symmetry will give us the matching point automatically. The axis of symmetry is x equals 2, so let's try x equals 1. Substituting x equals 1 into the function gives us y equals the negative of 1 squared plus 4 times 1 minus 2. That is -1 plus 4 minus 2, which gives us y equals 1. This gives us another point on the parabola, the point 1, 1. We have enough information to draw the graph. First, plot the axis of symmetry, which is the vertical line x equals 2. Next, plot the vertex at the point 2, 2. The y-intercept is the point 0, -2. This point is 2 units to the left of the axis of symmetry, so its matching point is 2 units to the right at 4, -2. We can also plot the additional point at 1, 1. It is 1 unit to the left of the axis of symmetry, so its matching point is at 3, 1. Finally, we draw a smooth curve through the points. Since the coefficient of x squared is negative, the parabola must open downwards, and the two sides must be symmetrical about the line x equals 2. That completes the second graph. Before we move on, if you're enjoying this video so far, please give it a like and consider subscribing to the channel. Thank you. Let's take a look at the third example. Graph the quadratic function y equals 2x squared plus 8x plus 8. Here, a is 2, b is 8, and c is 8. Since a is positive, this parabola opens upwards. We begin with the axis of symmetry. X equals negative 8 over 2 times 2. That is negative 8 over 4, which gives us x equals negative 2. The x-coordinate of the vertex is therefore negative 2. To find its y-coordinate, we substitute x equals negative 2 into the function. Y equals 2 times negative 2 squared plus 8 times negative 2 plus 8. That is 2 times 4 minus 16 plus 8. 8 minus 16 plus 8 gives us 0. So the vertex is the point, negative 2, 0. Now here's something worth noticing straight away. The vertex has a y-coordinate of 0, which means it sits exactly on the x-axis. Therefore, the vertex is also an x-intercept. Since the parabola opens upwards and the vertex is its lowest point, we expect this point to be the only x-intercept. Let's confirm this. To find the x-intercepts, we set y equal to 0. 0 equals 2x squared plus 8x plus 8. We then apply the quadratic formula, x equals negative 8 plus or minus the square root of 8 squared, minus 4 times 2 times 8 all over 2 times 2. This becomes x equals negative 8 plus or minus the square root of 64 minus 64 all over 4. The value inside the square root is 0, so we have x equals negative 8 plus or minus the square root of 0 all over 4. Since the square root of 0 is 0, both solutions are equal to negative 8 over 4, which gives us x equals negative 2. The two solutions coincide, so we have one repeated root. This confirms that the vertex and the only x-intercept are the same point, negative 2, 0. We can then find the y-intercept. When x equals 0, both terms containing x disappear, leaving us with c, which is 8. The y-intercept is therefore the point 0, 8. Since the vertex is also the only x-intercept, we need an additional point to help us draw the curve accurately. The axis of symmetry is x equals negative 2, so let's choose a nearby value and try x equals negative 1. Substituting x equals negative 1 gives us y equals 2 times negative 1 squared plus 8 times negative 1 plus 8. That is 2 times 1 minus 8 plus 8, which gives us y equals 2. This gives us the additional point negative 1, 2. We can use these points to draw the graph. Begin by plotting the axis of symmetry, which is the vertical line x equals negative 2. Then plot the vertex at negative 2, 0. Remember that this point is also the only x-intercept. Next, plot the y-intercept at 0, 8. This point is 2 units to the right of the axis of symmetry, so its matching point is 2 units to the left at negative 4, 8. The additional point is negative 1, 2. It is 1 unit to the right of the axis of symmetry, so its matching point is at negative 3, 2. Finally, draw a smooth, upward opening curve through the points, making sure that both sides are symmetrical about the line x equals negative 2. That completes the third graph. For our final example, let's graph the quadratic function y equals negative 2x squared plus 8x minus 9. Here, a is negative 2, b is 8, and c is negative 9. Since a is negative, this parabola opens downwards. We begin by finding the axis of symmetry. X equals negative 8 over 2 times negative 2. That is negative 8 over negative 4, which gives us x equals 2. The x-coordinate of the vertex is 2, so we substitute x equals 2 into the function. Y equals negative 2 times 2 squared plus 8 times 2 minus 9. That is negative 2 times 4 plus 16 minus 9, which gives us y equals negative 1. Therefore, the vertex is the point 2, negative 1. Before moving on, let's consider what the vertex tells us about the graph. The vertex has a negative y-coordinate, so it lies below the x-axis. We also know that the parabola opens downwards, which means that the vertex is its highest point. We therefore expect the parabola not to cross the x-axis. However, let's confirm this by following the usual steps. To find the x-intercepts, we set y equal to 0. 0 equals negative 2x squared plus 8x minus 9. We then apply the quadratic formula, x equals negative 8 plus or minus the square root of 8 squared minus 4 times negative 2 times negative 9, all over 2 times negative 2. This becomes x equals negative 8 plus or minus the square root of 64 minus 72, all over negative 4. At this point, the quadratic formula requires us to find the square root of a negative number. The quantity inside the square root is the discriminant. In this example, the discriminant, b squared minus 4ac, is negative. Since the square root of a negative number is not a real number, the quadratic equation has no real solutions. This means that the graph never crosses the x-axis, so there are no x-intercepts. This confirms what we expected. For the y-intercept, x equals 0 leaves us with just c, which is negative 9. The y-intercept is therefore the point 0, negative 9. Since there are no x-intercepts, we need an additional point to draw the curve accurately. The axis of symmetry is x equals 2, so let's choose a nearby value and try x equals 1. Substituting x equals 1 gives us y equals negative 2 times 1 squared plus 8 times 1, minus 9. That is negative 2 plus 8 minus 9, which gives us y equals negative 3. This gives us the additional point 1, negative 3. We can use these points to draw the final graph. Begin by plotting the axis of symmetry, which is the vertical line x equals 2. Then plot the vertex at the point 2, negative 1. Next, plot the y-intercept at 0, negative 9. This point is 2 units to the left of the axis of symmetry, so its matching point is 2 units to the right at 4, negative 9. The additional point is 1, negative 3. It is 1 unit to the left of the axis of symmetry, so its matching point is at 3, negative 3. Finally, draw a smooth, downward opening curve through the points, making sure that both sides are symmetrical about the line x equals 2. That completes the fourth and final graph. So that's how you graph a quadratic function using the vertex, the axis of symmetry, and the intercepts. The only formula you really need to memorize is the axis of symmetry. The vertex, the intercepts, and the symmetry of the curve all follow on from there. If there's a topic you'd like me to cover next, let me know in the comments below. Thanks so much for watching, and I'll see you in the next one.